Right now, we are talking about interfaces, specifically inheritance with interfaces, which means we have to talk about interfaces. In another video, I talked about inheritance with classes. So first of all, we have to define an interface. What is an interface? An interface defines a contract that classes agree to implement. Essentially, it means that interfaces provide methods that classes must implement. We'll go into this more in a minute. It describes what a class can do, but not how. That's abstraction. You're not worried about the implementation details. You just want to know what the method does. And it enables loose coupling and polymorphism. Now you kind of wonder, okay, what is loose coupling? We hear this term being thrown around all the time. Essentially, it means that you're relying more on abstractions than concrete implementations. So let's take a look at this example. So the way that you declare an interface is the word interface, just like you declare class with the class keyword. Interface payment processor, void process, which takes in an amount, which is a double. So this defines a method, but notice that there's no implementation body, just the method. That means that whatever class implements this interface must use this method. But the way it uses this method is up to the class implementing this interface. What's the purpose of an interface? Like I already mentioned, is to define capabilities without implementation. It can provide a method without providing the implementation details. It enables multiple inheritance of behavior contracts. Essentially, what this means is that a class can implement more than one interface. And as a result, it can take those methods from different interfaces and implement it however it wants, as long as it implements those methods. It can decouple code from concrete implementations. Again, it's relying on abstractions rather than concrete implementations. That abstraction is, okay, the interface is providing this method, but the concrete implementation is up to the class that's implementing this interface. And it supports API design and testability. So basically, APIs are basically programs that talk to each other. That's what APIs are. Most people, when they say API, they're thinking yeah, network APIs. Another thing is, I talked a little bit about loose coupling before, and I did say that it essentially means relying on abstractions rather than concrete implementations. What that really means is that if one part of the program breaks, it doesn't break the entire program. If one piece is not working, it doesn't mean that the whole program has to crash. All right, what are the key features of interfaces? So in interfaces, all methods are public by default. Fields are public static final. That essentially means that any field that you declare in an interface is a constant. And not only is it a constant, but it's bound to that interface. But it's publicly accessible. Excuse me, classes use implements. Essentially, what that means is that in order to use an interface, you have to use the implements keyword. You'll see that soon. It supports multiple interfaces. So that's that multiple inheritance I mentioned earlier. And interfaces, even though all methods are public by default, you can change the, the modifiers. So you can have default methods. So you can change the access modifiers. You have default methods, you can have static methods. And as of Java 9 and above, you can also have private helper methods. I use Java 17, and I think the latest edition of Java is 21, so we're good. All right, creating and implementing an interface. So the way you create an interface is with the keyword interface. So we're creating this logger interface, which has a method, an abstract method, which is a log method. And you pass it a string, and it logs it to the console. You have a file logger, which implements logger. And it implements the method log, which is implemented from the interface, which is inherited from the interface. And notice that here is where you add implementation details. So you're printing, it tells you how to print the message. And it makes sense because, okay, you have a logger class, you have to log things, so you need to do logger stuff. And that logger stuff is what you get from this interface. That's what you implement. All right. So let's talk about interfaces and how they relate to methods. So interfaces can be used as method parameters, and they can also be used as return types. So you can pass an argument of a type that's that interface. So interfaces can basically be used as return types, as I already mentioned. So when you pass this interface as an argument, or any class that implements this interface rather as an argument, you can control the implementation. Whichever class is calling the method can control the implementation, and the method stays generic and reusable. Interfaces as return types. You can return interfaces to hide implementation details. So let's say you have a class that implements an interface. You have another class that also implements the same interface. But those two classes may implement the methods in the interface a little differently. But you can still return those classes as return types, improving encapsulation. And you can allow different implementations from your return type without breaking your code. One example that we've been using all along is the list interface. So ArrayList implements the list interface, and it implements its methods. So we've been using that example already. So let's recap. Interfaces versus abstract classes. So interfaces, they support multiple inheritance, whereas abstract classes do not. Interfaces do not have any state. Abstract classes can have state. You just can't instantiate it. And neither interfaces nor abstract classes can be instantiated. It's not on the slide, but it's a very important detail to know. Interfaces focus on capability. They focus on functionality. Abstract classes focus on identity. Interfaces are pure contract. Abstract class, partial implementation. So let's explain these. So abstract class, when they say abstract classes focus on identity, what that means is if you're going to decide whether to use an abstract class or an interface, if you're concerned mainly with functionality, mainly with methods, and you want to use multiple inheritance, I would use an interface. So you use interface for behavior contracts. But if there's a lot of shared behavior, then I would use an abstract class. Like let's say, okay, you have an animal class. That can be your abstract class because in an animal class, it may have a lot of attributes and methods that you want to share with all the subclasses, such as dogs and cats and bears and lions and yeah. Abstract classes, if you have a lot of shared logic, you want to use those. And then pure contract, that means that you have to implement all the methods of an interface. Okay. Abstract methods for sure. An abstract class, you can have partial implementation. That means that you have some concrete methods and you have some abstract methods that you can implement. When to use interfaces is basically a recap to the beginning. If you need multiple inheritance, if you want loose coupling, if you're defining an API and you want to easily perform testing and mocking. So in short, interfaces define what a class can do, enables flexible design, and keeps systems loosely coupled. Abstract classes, on the other hand, define what a class is. Thank you. And let's move on to our IDE. Okay, we are back in Eclipse, and we will look at our sample interfaces. So let's look at our little lesson plan here. So we're going to look at the interface payment processor, and it demonstrates all the characteristics of the interfaces that we talked about. So let's look at our before we run this, let's look at our PayPal, well, not PayPal processor, that's another one. Let's look at our payment processor interface. Okay, so we have a field that's implicitly public, static, and final. This method is implicitly public and abstract. If you don't put any modifiers, it's implicitly public and abstract. This default method it just shows that you can have default methods in interfaces. Okay, and that's this validate method, which validates, it just makes sure that you're passing in a positive number when you're using the payment processor logic. And within limit. So we'll talk about this in a second. So this method, this log, it's it's tied to this interface, and it prints out a payment message. And you have this private helper method in Java 9 and above. Like I said before, I'm using 17. This within limit is also used, a private helper method. It's used within this. So this method is calling this method, but it's not inherited. So that's your payment processor. We'll touch on the auditable. It's going to take about 10 seconds for me to talk about. This is auditable. It implements a implicitly public method called audit. Okay. Yeah, public and abstract. Okay, let's go to our credit card processor. So as you can see, our credit card processor implements payment processor and auditable. So it's overriding this process. Okay, this process, this comes from the payment processor. This is the abstract method inherited, and we're giving it the implementation logic. Okay, we're giving it the implementation logic, and we're using the validate method from this payment processor. And we also have an audit method, which we inherited from auditable, and that's being implemented as well. And notice too that the payment processor, the static method from this payment processor, is also being utilized. So that's that. So I think with that, let's go back to our runner class. And then we're just going to start with running this. I'm going to comment out this for now. We'll talk about that in a minute. We'll save it. So let's run this. So we're gonna instantiate a credit processor and demonstrate that it validates the amount passed in and that it audits. as well. Okay. So yeah, so it processed $5,000. So it processed a credit card payment or credit card charge rather of $5,000. This was a negative number, so the validation, it validated it, and it did not pass validation, and it audited. So so here we go. And now we're gonna comment this out. We'll comment all this back in, and we'll talk about being able to use these interfaces as both parameters and return types and method. So, so let's go and look at our payment. Well, payment processor is an interface, so it can be used as a type. Okay, it can be used as a reference type, and it can be used as a reference type in methods. Okay, so I think the best thing is to look at our payment service. So here's our payment service. So it has two methods. It has a method that takes in a payment processor as an argument as well as a double. So the payment processor, it's a general type. So any object that implements the payment processor interface can be used. So let's digress for a moment. There's a PayPal processor that I added, and it implements payment processor, but it does not implement Audible. And it's implementing the method a little differently here. But the thing is, if you're too specific and like, let's say if you made this return type PayPal processor, then that means you cannot use credit card processor and vice versa. So by being able to pass in payment processor as an argument, you can use any processor that implements the PayPal processor. That you can use PayPal processor or you can use payment processor. So what I'm trying to say is because credit card processor and PayPal processor both implement payment processor, you can use credit card processor and PayPal processor interchangeably. You can pass these in and you can still execute this method. That's what's meant by loose coupling. By loose coupling, having a slightly different class that implements the same interface does not break the program. Now using an interface as a return type. So again, you can pass in either an object of the PayPal processor type or the credit card processor type. And you can decide how to implement it. So if you pass in credit, so if you pass in credit, then you can create a new credit card processor and return this. If you pass in PayPal, then you can create a PayPal processor and return this. And then whatever processor that you're returning, you can use the methods inherited from payment processor, but implemented it in different fashion. So let's go back to our runner. So let's go back to our runner. So yeah, if you use an interface as a parameter, it allows any payment processor implementation to be passed in, like I already mentioned, and it allows flexibility. It adheres to the dependency inversion principle, which is the D in solid. You can also use interfaces as return types, as already mentioned, and you can return different implementations based on logic, and you can easily swap and extend without changing the method signature. So that's an important thing. You don't have to change the method signature. Like you don't have to change the method signature to use a PayPal processor or a credit card processor when you can just use payment processor. So let's run this and demonstrate. So one thing is, this is going to return a credit card processor. This will return a PayPal processor. but they're both going to execute the payments. Okay. So this credit card processor processed $150. This PayPal processed $75. All right. We're done here. I hope you learned something. Subscribe and peace out. Bye.